Alright, it's Niaki Osteozone. So today we are going to continue with the Niaki chemistry series, and we are continuing with electrochemistry. So in our previous session we did electrolysis. So if you haven't checked on our playlist, you need to do so. We are providing massive topical revisions in all the science subjects. We have a lot of tutors who specialize in different specialties, so we got you covered. So what you only need to do is to subscribe to our YouTube channel so that you'll be notified whenever we post, right? So electrochemistry is one of the crucial topics in chemistry, so we need to have a step-by-step understanding of the fundamental principles, the fundamental concept within these topics, right? So we are dissecting each and every objective of the syllabi so that you can fully understand. So in the previous session we did talk about electrolysis, we did talk about electrolysis, and now we are moving on to what we call electric cells. So we have electrolytic cells which convert they convert electrical energy into chemical. And then we have these electric cells which we are going to discuss today. They convert chemical into electrical. So you should take note of the difference. So here we are using a power source, and then here we are producing a power source. So this is the fundamental building block of a battery, right? So this is the fundamental building block of a battery, which is defined as a collection of cells. So a battery is defined as a collection of cells. So you should understand, you should be able to define the term battery. Are we together, guys? So this is what you need to know, this is what you need to understand when we are dealing with electric cells. So we have the building blocks of electric cells, we have the parts of electric cells. So each cell, you've got an anode, we have the electrodes, right? We have the electrodes, the anode and the cathode, and we also have the electrolyte. So we have defined these terms before, right? So anode is defined as the electrode where oxidation takes place, and then cathode is defined as the electrode where we are having reduction, right? Where we are having reduction. And then we said we have this mnemonic which says red cat, and then N ox. So red cat is reduction, cathode, and then in ox, anode, oxidation. Are we together? So this is what you need to understand. And then electrolyte defined as an ionic compound which can allow electric current to pass through it, right? So this is the definition for an electrolyte. Ionic compound, you must take note of that. It's an ionic compound. So if you are to use a covalent molecule, a covalent compound, we must first ionize it. So we did talk about it when we were alluding to the electrolysis of water. So first we said water must be ionized by adding either sulfuric acid, either hydrochloric acid, or any of the strong acids, right? Or we can use stable salts, we can use sodium sulfate, we can use sodium sulfate, right? So first we must ionize water to increase its conductivity. So we did electrolysis of water. So for now we want to dissect the electric cells. So we have two types of cells. We have what you call the primary cells, and then we have what you call the secondary cells. So these are the two types of electric cells. So a primary cell is defined as a cell which cannot be recharged. And then this one, a secondary cell, can be recharged. So we must understand the differences, right? Are we together, guys? And then we can also explain the difference, the examples, right? So here we are having a dry cell, and then here we are having a lead acid accumulator battery of the car, right? So these are the typical examples you must understand, and they are often examined in your examinations, right? And they are often examined. So this is what you need to understand, right? And then we said we have the confusion when naming electrodes. So the naming of electrodes. So here we defined anode is the electrode where we are having oxidation, and then cathode is the electrode where we are having reduction, right? So we never say cathode is the positive, this one is the negative. We never say that. We define these in terms of the redox reactions. So you must first understand the definition of these electrodes. We define the anode and the cathode with respect to the redox processes, the redox reactions, oxidation and reduction. Are we together, guys? So here we want to first explain using the electrolytic cell, like we have alluded to before. So we said the one, so we have a battery, right? The external power source. So this is the external power source, and then the one connected to the positive. So the longer line is the positive terminal, and then this shorter line is the negative. So the one connected to the positive is the anode, right? And then the one connected to the negative is the cathode. Are we together? So this is what you need to understand. The cathode is the negative terminal, the anode is the positive terminal for the electrolytic cell, the one we did in the previous session, right? And then today we are talking about electric cell. So this one is the electrolytic cell. This one is the electric cell. So this one converts electrical energy into chemical energy. And then this one, the electric cell, it converts chemical into electrical. So you must understand the difference, you must know the difference. So for naming the electrodes, it's simply the opposite. So here the anode is the positive. So for this one, anode is the negative. So I'm going to explain why, right? So I'm going to explain, and then cathode is the positive terminal, right? So you must first understand, you must know this by heart. You must know this difference by heart. Are you together? So we said anode is negative terminal. So let us say we are having this one, the series, the circuit, and then here we're having this bulb, right? And then we're having these electrodes, and then we're having this container, the electrolyte, right? With the electrolyte. Are we together, guys? So this is the container. So we said anode is where oxidation takes place, right? That's what we said. Anode is where oxidation takes place, and we defined oxidation as the loss of electrons, right? Are we together, guys? So here we are going to lose electrons, right? We are going to have an excess of electrons so that we can lose the electrons. So if this one is our anode, we're going to lose electrons from here, meaning to say it has got a high concentration of electrons since we are losing some of them, right? It is highly concentrated with electrons. So electrons, they are going to move from this anode. So this one is our anode. Why? Because it has got a high concentration of electrons. Are we together? So electrons are going to move from the anode. So you must know this also. Electrons move from the anode to the cathode. So this is the direction of the electrons from anode to the cathode. And then this cathode is defined by red cat. So cathode, that's where we are having reduction, the gaining of electrons, right? Are we together, guys? So here we are gaining electrons, meaning to say within this electrode we are having a negative charge, right? We are having a negative center. So for us to gain more electrons, we need to create a hole whereby we are going to create an electron deficient region. Electron deficient region, right? So that we can gain as more electrons as we can, right? So we are going to have this electron deficient region, right? So this electron deficient region will give us this positive sign so that we can easily attract these negative electrons. So negative and negative attract. That's why the cathode is said to be the positive terminal. Are we together? So I hope this is very, very clear to you guys. I hope you can fully understand. So let us say we are given elements. Let us say we are given this one is zinc, and then this one is copper. So zinc is going to be the anode, and then copper is going to be the cathode. So you can have the reactivity series. That's why we are going to apply the reactivity series. So the one which is more reactive is going to lose electrons, and we said where we are losing electrons is the anode. So zinc is more reactive than copper. So obviously zinc is going to release or to lose the electrons, and then copper is going to receive. So this is what you need to know. So you must know the reactivity series by heart, right? You must know the reactivity series by heart. So you need to also take note of the direction of the flow of electrons, and also to know the direction of flow of current. So current flows from this positive. So the flow of current, and then this one is the flow of electrons. Are we together? You must be able to give these differences, right? So this is what you need to understand for the electric cells. These are the differences we have between the electric cells and the electrolytic cell. Are we together, guys? So we also have another issue of interest, which is called the polarization. Polarization, right? So this is the polarization. So polarization is defined as the accumulation of the hydrogen gas. So polarization is defined as the accumulation of a hydrogen gas on the cathode during the chemical reaction inside the cell or the simple cell. So here we have this bulb. So the bulb will light. Why? Because current is flowing, right? So you must understand that. So if you have a voltmeter, you can note the deflection in the voltmeter, right? So here there will be some changes on this indicator. So this one is will indicate the flow of current. This is the purpose of this bulb, right? To indicate the flow of current. Current flows from this one to this one, and then electrons from this one to this one. So you must understand that. And then we said polarization is the accumulation of the hydrogen gas on the cathode. So this will happen especially in simple cells. So this will happen especially in simple cells, right? So we say that at the cathode, electrons are being gained, right? Electrons are being gained. So in the solution, we are having the protons, the hydrogen ions. So they will gain electron, and then they will form the hydrogen gas, and then we can balance both stoichiometrically and ionically, right? And then we are going to have the aqueous. So this one, this electrolyte has got some protons, right? Since it is in aqueous form, aqueous meaning to say it has got water within ionized to give the protons and the hydroxide ions, right? So this is what you need to know. And then protons are being reduced to give hydrogen gas. So this hydrogen gas will then absorption on the cathode, the absorption of the hydrogen gas, right? So we have the effects of this polarization method, polarization reaction. We have the increase in the resistance, right? And also there is a reduction in the voltage, the output voltage, right? The output voltage of the cell, and current will eventually stop flowing, right? Stop flowing. So these are the effects of the polarization on the cathode, right? So we have the solution. We have what you call the depolarizer, right? We have the depolarizer. So a depolarizer, it is defined as a chemical. That removes hydrogen, right? That removes hydrogen as it forms. So the examples we have manganese dioxide, manganese dioxide. So this is the chemical formula, right? And we also have potassium dichromate, right? At times we can use potassium dichromate. And we can also use the manual way. We can shake or stir the electrolyte to release the gas bubbles, right? So these are the solutions to the polarization. We can use the depolarizer, we can use the depolarizer, right? So this is the general introduction to electric cells. This is what you need to understand from the electric cells. So before we venture into specific the dry cell and the lead acid accumulator, this is what you need to know, right? So after the use of the depolarizer, cell starts functioning again, right? So we can also wipe the bubbles from the electrode, right? So this is the general information you need to know about the electric cells before we venture into specifically dry cell and the lead acid accumulator, right? And also you need to take note that so here we used zinc and copper, right? Here we used zinc and copper. So if you are to have sodium here and then gold here, the further apart the metals on the reactivity series, they will have a higher voltage. So if you are having elements here or metals here which are further apart on the reactivity series, they are going to give us a higher voltage, right? So here we are using a bulb. So this will simply mean to say the bulb is going to light brighter, right? The bulb is going to light brighter if you use metals which are far apart on the reactivity series. Are we together, guys? So this is what you need to know. And then we are moving straight to the dry cell, right? So we are having a dry cell. So a dry cell, it is a primary cell, right? It cannot be rechargeable. It cannot not recharged, right? And then it converts a chemical into electrical. It converts chemical into electrical, right? And then you must know why it is called the dry cell. So it is called the dry cell because it uses a paste electrolyte, not a liquid one. Why? Because it uses a paste electrolyte, not a liquid one. So we said a paste. When we say this one is a paste, we mean to say it is not a liquid, but it is in the form of a Colgate-like phase, right? The mountain phase, right? And then we can now move on to the components of a dry cell. The components of a dry cell. So we are having a carbon rod, and then we are having a zinc cane, and then we are also having ammonium chloride paste, and then we are going also to have mixture of powdered carbon and manganese dioxide. So manganese dioxide is used as a depolarizer, like we have alluded to before, right? And then now we are going to explain the use and the function of each of these components, right? So we are going to have the zinc cane first. So zinc cane is the anode, right? It is the anode, the negative terminal, the negative electrode, right? So the zinc cane will provide, it is going to release the electrons, right? Zinc is going to release the electrons. So we defined anode as the electrode which releases electrons. Anode defined as the electrode where oxidation takes place, right? And then we are going to have the carbon. So carbon in the form of graphite. Always remember that. Carbon in the form of graphite, the allotrope. So graphite or carbon, it collects the electrons, and it is also surrounded by the depolarizer. surrounded by manganese dioxide, the depolarizing agent, right? And then we also have ammonium chloride paste. So this one is our electrolyte, right? So ammonium chloride paste is our electrolyte. So it allows, so it is the electrolyte, right? So it contains the ammonium ion and also the chloride ion. So these ions are able to conduct electric current, right? So these ions, they are able to move. This will allow what we call ionic conduction between the anode and the cathode, right? So this will allow ionic conduction between the cathode and the anode, thereby also completing the internal circuit. Are we together? So this is what you need to know for ammonium chloride paste, the electrolyte. And what else do we have? This one is our depolarizer, like we have said before. We also have the insulator. So usually the insulator can be a cardboard or a plastic, or a plastic case, right? So this prevents short circuiting. So this prevents short circuiting. Are we together, guys? So these are the functions of the components we have in a dry cell. So at times can be examined to give the anode reaction and the cathode reaction. So for the anode, zinc is going to be oxidized to give the zinc ion plus two electrons, right? And then zinc is the negative electrode. You must always remember that. And then we go on to the cathode. So for the cathode reaction, so cathode, it is the positive terminal, right? So for the cathode, we are going to have the ammonium ion being reduced to give ammonia gas plus hydrogen, right? So we can balance this equation by simply having a 2 here and a 2 there, right? And then since we are producing this gas, we must have our depolarizing agent in action to remove the produced hydrogen gas, right? So this is the equation, right? So we say that electrons, they flow from anode to cathode, and then so this is the flow of electrons, and then current will flow from cathode to anode. So this is the flow of current, as simple as that. And then we are also going to have, so this cell will provide a potential difference of about 1.5 volts, right? And then we are going to have the advantages. We're going to have the advantages of the dry cell. So they are starting with the cost. So it is a low cost one. So it is a low cost cell, right? And then also portable and compact, right? And then also easy to use, right? And then also useful for small devices, right? And then for the disadvantages, we can say that it is not rechargeable. So this is the main disadvantages, right? And then we can also say that it is for limited life, since the zinc container can gradually wear off, right? And then we can also say that the paste can leak out, right? The paste can leak out when the battery is old, and then voltage will decrease with the age of the battery, when the battery is in continuous use, right? When the battery is in continuous use, right? So this is what you need to know, this is what you need to understand for the dry cell. Are we together, guys? So we are now moving on to the lead acid accumulator, and then the lead acid accumulator. So this one is a secondary cell, meaning to say it can be recharged, right? So this is the difference between the dry cell and this one. The dry cell cannot be recharged because it is a primary cell. This one can be recharged. That's why it is said to be a secondary cell. So we have the components of this type of cell. So we have the anode, the negative one, which is the lead plate, Pb, chemical symbol. And then we have the cathode, which is the positive terminal, which is lead 4 oxide, right? So we can say lead dioxide, still the same with lead 4 oxide, right? And then we also have the electrolyte, electrolyte, which is dilute. So you must take note of the term dilute sulfuric acid. And then we're going to have the container, which is oftenly the hard rubber or plastic casing, right? Plastic case. And then we're going to have the separators. We can have the porous insulators. Are we together, guys? So these are the components of the lead acid accumulator battery. So we must know the anode, the cathode, the electrolyte, and then the container, and then the separator. So you should be able to give the functions of each. So this one will give away the electrons, right? This one will act as the negative terminal. The anode defined by the electrode which is going to release the electrons. So this one will release the electrons, and then this one you gain the electrons. And then this one, the electrolyte. So electrolyte allows the movement of ions, right? And then the container, this rubber plate, will hold the plate and the acid safely. So we hold the plates and the acid safely. And then now we're going to have the separators, so they will keep plates apart, but they will let the ions pass, right? So this is what you need to know. So we can now dive into the chemical reactions. We can now dive into the chemical reactions at the cathode and at the anode. So here the main energy change we are having, we say it is chemical to electrical, right? We say it is chemical to electrical. So the chemical equation we are going to have at the anode, we're going to have lead metal plus the sulfate ion to give lead sulfate plus 2 electrons. Simple as that. And then so this is lead 2, right? It's not lead 4. Lead 4, we're having lead 4 at the cathode, not the anode, right? So you must take note of that. And then at the cathode reaction, we're going to have lead 4 plus the proton from the acid plus the sulfate ion to give the lead 2 sulfate plus water. So to balance this equation, we can have a 2 here and then a 4 there, and then we can have two electrons here, right? So the overall reaction, we can simply add these two equations. So this one will cancel out with this one because they are on the opposite side of the equation, right? So we are going to have Pb lead plus lead dioxide to give plus 2 moles of sulfuric acid to give 2 moles of lead 2 sulfate plus 2 moles of water. So this is the overall reaction, right? So once the concentration of sulfuric acid starts to decrease, the cell or the battery becomes weaker, right? Once the concentration of the electrolyte starts to decrease, the battery becomes weaker. So these are the equations for the discharging when we are using the battery, right? So these are the equations for the discharging. So since we said it's a secondary cell, we want to have the equations when we are recharging the battery, right? So when we are recharging the battery, the reactions are reversed, right? The reactions are reversed. So here we said we are changing chemical into electrical. So here we are now changing electrical to chemical. So you must take note of the difference when charging. So this is when charging the battery, right? When charging the battery. So when charging the battery, lead and lead dioxide are reformed again, and then the acid becomes stronger and the cell will gain its charge, right? So lead and lead dioxide are reformed again, and then the acid becomes stronger again, and also the cell regains its charge. Are we together? So this is what you need to know. And also remember that the cell will produce a voltage of about 2 volts, right? So this is a takeaway. So this is a high yield, right? So this is high yield. And then we can have the equations during charging, right? So during charging, we said it's a reverse process. So charging is one and the same thing with the electrolytic cell, meaning to say the electrode connected to the positive terminal will become the anode, and then the one connected to the negative terminal is the cathode. So electrode connected to the negative terminal is our cathode, right? So this is when we are charging the battery, right? So you must understand that we are reversing the reactions. So we are going to have the reaction plus 2 electrons to give the lead metal plus the sulfate ion, and then the electrode connected to the positive terminal is going to be our anode, right? We say this one is the cathode, so this one is going to be our anode, right? So for the anode reactions, we are going to have lead 2 sulfate plus 2 moles of water, and then this will give us lead 4 oxide plus the proton plus the sulfate ion. So to balance, we can have a 4 here, since we are reversing the reactions, right? And then here we are going to have two electrons, right? So this is the anode reaction when charging, and this one is the cathode reaction when charging, right? So when charging, the energy change we are having electrical into chemical, right? So this is what you need to know. And also you can need to understand the advantages. You need to have the advantages and the disadvantages, right? So the advantages, we are going to have high power output, since we said we are going to have 2 volts output of about 2 volts. And then it is cheaper, right? Cheaper since it is rechargeable. And also you can say high efficiency. And then you can also say that it is reliable. It is reliable, right? And then we go on to the disadvantages. The disadvantages of this type of cell. We are going to have the slow charging processes, right? Slow charging. And also it is toxic and environmental hazard. Why? Because it contains lead, the heavy metals, and also sulfuric acid, right? Because of lead and sulfuric acid, which are difficult to dispose. And also you can have a limited cycle life. And then slow charging, limited cycle life, and toxicity. And also it is heavy and bulky, and contains a corrosive acid, right? Sulfuric acid, right? Contains a corrosive acid, and can be damaged by overcharging, right? Also can be damaged by overcharging, right? Or being left uncharged, right? So for the common uses, we can use it as a car and truck batteries, right? And then for solar battery. And then we can use it as a power backup system. So backup power systems, as simple as that. So this is what you need to know concerning the lead acid accumulator battery. And we are done with the secondary and the primary cells, the electric cells.